So, as I said, so here the word olefins is generally used to denote that hydrocarbons that contain at least one double bond. Okay,
Yeah.
so that's why we call alkenes as olefins also. And coming to the bond formation, it contains a carbon-carbon double bond. This is the other one. Apart from that, the terminal alkenes have the double bond at the end of the carbon chain.
Yeah.
Yes. So when I say terminal alkenes, the alkenes at the end, so they have double bond. Like for example, if I just give you a rough diagram here, so something like this. So think this is an alkene structure. Okay. So at the end of it, what you will find is a carbon-carbon double bond. Okay. So that is what we call as a terminal alkene. Okay.
Okay.
And then, and when I talk about the structure of the alkene, so as I said, it's a double bond between the two carbon atoms. Okay, then carbon, of course, linked to other elements as well. So here is a double bond structure. Apart from this, we have alkenes in what do you say? In a closed structure as well. So it might be something like this. And the reason why I'm putting a double line here indicates the presence of a double bond. So what kind of an alkene can you call this? We call this as cycloalkene.
Okay.
And this, of course, is terminal alkene. So alkene, which has a terminal, I mean, a double bond at the end of the carbon chain or the end of that alkene. Okay.
Yeah.
So coming to the properties of carbon-carbon double bond, one should try to understand. So rotations can occur if there is a break in the double bond and then it reforms. Now you have to try to understand what a pi bond is, what a sigma bond is. Okay. So this is another important one because when you say double bond, let me explain to you how a double bond actually forms. For example, let me take a carbon atom. Carbon has an atomic number of 6.
Yeah.
So the electron distribution would be 2 and 4. So even in
Yeah.
this 4, I'll tell you 2 here would be like this. And coming to this 4, the distribution goes like this: 1, 2, 3, and 4. So I have two orbitals which have unpaired electrons in it.
Wait, so I think you explained this last time.
Yes. Now I have to go a step further.
Okay.
Okay. Now, likewise, we're going to have another carbon atom
Yeah.
with the same formation.
Yes.
Okay. So now what's going to happen is just try to understand. So the same scenario here again. So how I can draw this is if I have a carbon atom with this and see this, these are the orbitals. So I can call this as X, Y, and Z. Okay. So
Yeah.
try to understand that this might be the Z orbital. And here I have another orbital. This might be the Y one.
Yeah.
Okay. Now, this is for this carbon atom. So likewise, we have another carbon atom involved here.
Yeah.
Same structure here. I can put it even like this. So now try to understand these two, okay, this carbon atom and this one, they will start approaching each other.
Yeah.
Okay, and there will be a stage when the horizontal orbits will overlap each other horizontally.
Okay.
Okay, so during this overlap, this bond formation, because it's called as an end on end overlap.
Yeah.
Yes, this is an overlap which has happened end on end. So I'm going to call this bond as a sigma bond.
Oh, yes.
Okay. And
Yep.
similarly, now I have y orbitals here, which are sidewards like this. Now
Aren't
this
they like,
overlap is going to be slightly different from the previous one which I showed. So this is called as a side-on overlap.
okay,
And this bond formation is called as the pi bond. What do you call it?
a pi bond?
A pi bond. Sigma is this. So try to understand whenever there's a double bond, okay, of a carbon atom, the two bonds that will actually form here is one, the sigma bond, and then we have the pi bond formations here.
Yep.
Is this part clear?
Yes.
Okay. So that's what it says. So a double bond consists of a pi bond and a sigma bond. Understood? Now this is called something as an sp2 hybridization. Now you must be wondering, so what is sp2 hybridization?
Oh, I think I already know that.
Yes, this is the s orbital that we're talking about. This is the p orbital we're talking about. So we call it as an sp2 hybridization. Okay. And the bond angles during these, bond formations, it is roughly approximately around 120 degrees, the bond angle that is involved in this. Okay.
Yep.
So now we understood how exactly are the pi bond and sigma bonds actually forming here.
Yep.
Okay. Now, this of course is to have a formation between two carbon atoms. Okay. Now, what
Yes.
it says here is, apart from that, there will be bond dissociation energies of the carbon atoms in ethane and ethylene as well. Understood?
Yep.
So when I said dissociation, it is to break the bond. So
Yes.
some amount of energy would be used up here, okay, for this dissociation to take place. Because you see, there are two overlaps that have been formed. One is the end-on-end overlap, resulting in a sigma bond, and the side-on overlap that results in the formation of a pi bond. Okay. Now, can you guess? Can you guess, just by looking at the diagram, which bonds must be more stronger uh, between the sigma bond and pi bond?
Isn't it depending on whichever hybridization is?
It's not depending on hybridization, but it depends on which type of an overlap are we talking about. So, and why?
End?
Yes, on end-on-end overlap, whenever it takes place, it results in the formation of sigma bond, where the overlap of the orbitals is maximum.
Okay.
Because it overlaps for a larger area, the bonds are much stronger in relation to the pi bonds. So what I
Yeah.
can say here is sigma bonds are much stronger than pi bonds because of the extent of overlap being more in sigma bonds.
Yeah.
Understood? So pi bonds are much weaker than sigma bonds. Okay. So because of this, a carbon-carbon double bond can be easily broken. Understood?
Yep.
Because you have one strong bond and one weak bond. Even if there's a one weak bond, it becomes very easy to break that bond actually here. So now let me go back to before alkenes. What was that we learned?
Alkynes. No.
Alkanes. So now, as a result of these, one weak and one strong bond being formed here, so
Yep.
alkenes actually undergo many reactions that the alkanes do not go.
Is it that why they're like double? So then
Yes, yes, because
increases?
yes. So, like for example, if I tell you, now I just showed you the diagram of a cycloalkene there.
Yep.
Yes. So cycloalkenes normally when they have fewer than eight carbon atoms, okay. So then they actually have a carbon chain long enough to connect the ends of a double bond, okay, without much strain. Understood? Because see, you have a double bond there, so it can actually easily enter into another bond formation with the adjacent, atoms, for example.
Yep.
So yeah, that is one thing. Now coming to the property of these carbon-carbon double bonds, let me tell you the rotation, because I told you there's a bond angle also involved here. The bond angle is roughly about 120 degrees. Okay.
Yep.
So the rotation around the carbon double bond or the carbon-carbon double bond is restricted. Okay.
Okay.
Now why? Because rotation here can happen or can occur if the pi bond breaks and then it reforms, okay, which is not actually favorable.
Okay.
So that is the reason the rotation of these carbon-carbon double bonds is a bit restricted. Understood?
Yep.
And now, let me tell you one more thing. The next one, what we're going to call is something like stereo isomerism. I told you what are isomers the other day.
Yes, you did.
Did I?
Well,
Same
you
formula, different
mentioned it.
structures. Same formula, different structures.
Well, you mentioned it. I can't remember what they are, but
Yes,
you
yes,
did
yes.
mention it.
So whenever the two groups of each end of a carbon-carbon double bond are different from other, then we have diastereom. What do you call it?
Oh, yes, you did. And you
Diastereomers.
showed me. Yeah.
Yes, yes, yes. Okay.
Yes, now I remember what they are. Same formula, but different structures. Yep.
Yes. So here we have two types of alkenes here. One is called the trans cyclooctene, and the other one is called cis cyclooctene.
Okay.
Okay. So when I say trans cyclooctene, it is the smallest isolable trans cycloalkene, but it is less stable than your, cis cyclooctene. Now, I'll just what to say, share these structures of these. Okay.
Yep.
So coming to its stability, now trans alkenes are generally more stable than the cis alkenes. Try to get this point. Trans alkenes are generally more stable than cis alkenes. Let me make that point.
What are transalkenes?
Let me tell you. That's what I was saying just now. Trans alkenes. One second. First, let me make this point here. Trans alkenes are more stable than cis alkenes. Okay. So you generally understood now what trans alkenes and I mean not trans alkenes. Generally, what kind of a formation, uh, what kind of bond formation is found in alkenes?
Yep.
What is the basic difference between alkene and
Trans
alkene? Is a type of double bonds, right?
on. Yep.
Yes. So now let's come to the difference between the cis alkene and trans alkene. Okay. Now, if you look at these two words, there is a prefix here. One is trans, the other is cis, right?
Yes.
Yeah. So when I say cis alkenes, it indicates that the functional groups are on the same side of some plane. So suppose we have functional group like glycerol or aldehyde. Okay, they all are on the same side of a particular plane. Like how do I tell you? 1 second. Suppose uh, there is a chain over here. So
Yep.
all the functional groups will be on the same side of the plane
Okay.
in a cis alkene. Now, when I'm talking about a trans alkene, here I cannot guarantee you that these functional groups are going to be on one side only. Okay. So
Okay.
here trans conveys that they are on opposing sides or on the opposite sides. Okay.
So will they just be like more spread out with trans and then
Exactly.
this is just like
Yes,
they're all on one
exactly.
side?
So in cis alkene, what happens is the functional groups are on the same side of the plane. Understood? But
Yep.
whereas in a trans alkene, they're on the opposing side or they're on the opposite sides. Okay.
Yep.
Now, did I give you the general formula for alkenes? I did.
You sent it all as
Yes.
one. Yep.
So now can you tell me what's the general formula for alkene?
I Can I alkane? No, I can't.
Alkenes. Okay, fine, no problems.
Well, I mean,
CN.
I don't think you sent it, and nor do
Yeah,
I
no,
know.
I did.
Wait, then
CnH2n. We did this the other day.
CnH2n. Oh,
Yes, we
but
did.
aren't they like different things anyways?
No. I mean, yeah, it's different from alkane and alkane, of course.
But
Okay.
isn't the formula different?
Yes, it is.
Oh, okay.
So the general structural formula for alkene is CnH2n. And here, what can we say now? Alkenes are unsaturated hydrocarbons. Okay, because they have fewer than maximum number of hydrogen atoms per carbon. Try to
Yeah.
understand. They have fewer than maximum number of hydrogen atoms per carbon. So as we say, they are hydrocarbons. So now, when you compare, now I'll just explain it. It's all in the formula. Suppose if I take n is equal to 2.
Yes.
So if I say it is C2,
Oh
then
yeah, you explained it
H
the other
would be
day.
yes. Now
Yeah.
compared to carbons, do we have the same number of hydrogens?
No, it's always two more.
So there are more. So
Yes.
that is what was the meaning of this sentence which I just told. So alkenes have fewer than maximum number of hydrogen atoms per carbon. So in
Okay.
comparison to carbon, hydrogen atoms are more in number. Okay, fine. And here, as we know, whenever there's a bond formation between two carbon atoms, there's going to be two bonds, a double bond, which will involve sigma and pi bonds. Okay.
Yeah.
And now here, each pi bond or a ring removes two hydrogen atoms from a molecule, and that is where it introduces 1 degree of unsaturation. So what does that mean? When I say number of degrees of unsaturation for a given molecular formula can be calculated by comparing the actual number of hydrogen atoms in a compound to the maximum number of hydrogen atoms possible for the number of carbons present. Okay, if the molecule was a straight chain alkane, like for example, I'll give you a structure for C4H6.
Yeah.
Now, how can that come? Just let me show you. So here, this is one. So here we have two rings, 1 and 2. Okay. The same structure can even be written like this. I'll show up a double bond here and here. Okay.
Yeah.
So here, this shows that there are two pi bonds in this. Okay.
Is that just because of the lines?
Exactly. The line indicates that double bond.
Oh.
Okay.
So that's how you're gonna know if it's an alkene,
Yes,
just because of the
exactly.
lines.
Yes.
So if they added one more, then it will be an alkyne.
Hmm.
Okay.
Okay. Is this
Do I need
understood?
to only remember alkane, alkene, and alkyne, or do I need to remember the other two?
One is the third. The fourth one is, of course, the aromatic hydrocarbon.
Yeah, that one.
That's the one you actually need to understand. So, of
Oh,
course, the
that
next
one I
one.
need to? Oh,
Yes. Of course, the
okay.
next one is now physical properties. Okay. Physical properties of alkenes. Now, what he said here is most alkenes exhibit one weak van der Waals interaction, so their physical properties are similar to alkanes or of comparable molecular weight. Now, when we say most of the alkenes exhibit this weak van der Waals interactions, so sometimes what happens is even these alkenes also will try to get the properties of alkanes.
Okay.
Okay, there is a possibility of this as well. And secondly, the melting and boiling points keep increasing as the number of carbons increase. Because
Oh,
as the number of carbon increases, subsequently the number of hydrogens do increase. Like for
yeah.
example, just now I said CnH2n. If I'm using n is equal to 2, then I'm getting 4 hydrogen atoms here. If I use
Won't n
3,
will always equal to 2?
no, it starts from 1, 1, 2, 3, 4. You can just keep going.
But
Understood?
hydrogen will always be 2 more than carbons, right?
In
Always?
alkenes.
Okay.
Yeah.
In alkane
Okay.
and alkenes?
Alkane is going to be different.
Oh, okay. So only
I
in
did,
alkene.
yes. Okay. And the melting, that's the reason I'm saying melting and boiling points increase as the number of carbon increases. Because as the carbons increase, what happens is we know the hydrogens also it's going to increase at the same time. And so that increases the surface area. Okay. Apart from that, alkenes are soluble in organic solvents and it is insoluble in water.
What?
Alkenes cannot be soluble in water. See, I even told you that this the other day. There are some substances which are polar. There are substances which are non-polar.
Yes.
Now you cannot have the polar substances dissolving in a polar solute dissolving in a non-polar solvent or
Yeah.
a polar solvent, okay, that can dissolve a non-polar solute. It can highly be impossible. For example, you must have heard about naphthalene balls, right?
Yeah.
Naphtha, yes. You try to what do you say dissolve this naphtha in water, it doesn't. Instead, if I use naphthalene and benzene, the naphtha gets dissolved immediately.
Okay.
Yes. So polar dissolves in polar, non-polar dissolves in non-polar. Understood
Okay.
that?
Yes.
Yes. So these are some of the physical properties. And now, can you just tell me? Let me ask you. Where is polyethylene used?
Polyethylene? What? I've never heard of
Poly
that.
polyethylene.
I've never heard of that.
Is it?
Yep. Never ever heard of that.
Okay. Do you get bottled soft drinks? Okay.
Yes.
For example, Coke,
Yes.
XYZ, whatever, Pepsi or Coke. What is that bottle called as?
What does a bottle contain?
What kind of a bottle? No, no. What kind of bottle do we call it?
Oh, just a plastic bottle.
No, you just don't call it as plastic bottle.
No, we just call it a Coke bottle.
No. Don't you call it as a PET bottle?
Nope.
PET, P-E-T?
Nope.
No. Okay.
We just say, oh, bottle of Coke or bottle of whatever.
Oh, okay. But technically, scientifically, it has got a name like PET. So we call it as
What?
polyethylene terephthalate, PET. Okay. All your Coke bottles or Pepsi, Pepsi, whatever stuff.
Is it just
Uh,
because of the elements in there or something?
that's nothing but a long form chain of carbon and hydrogens.
Okay, that kind of
Yes.
makes sense when you do shake it and then it just goes.
Mm.
Yeah.
Okay. So the material which is used to make these bottles is the same thing. Polyethylene terephthalate. So that's a short form, PET. Okay.
Okay.
Let me ask you something else here now. Apart from that, have you ever heard the word ethanol?
Yes.
Now tell me, where is ethanol used?
They use it for like camping and stuff like that because it's flammable.
Okay.
I think
So
I'm thinking of the right thing.
yes.
Like you
So
get it like a bottle and then you can just flame it.
so ethanol can be used as a fuel. Okay. It can be
Yeah,
used
I've
as a
seen it at the
fuel.
petrol station.
Yes, it can also be used as a solvent. Okay. Now, next question. Where is PVC used?
PVC,
Yes.
like PVC pipes.
Oh, you know that. That's good.
Isn't that like used in like buildings and constructions?
Yes. I mean, yeah, pipes are one example. Okay.
They're
Do you
used in
have your,
plumbing, right?
yeah, do you have chargers around you, no? Mobile chargers or something?
Yep.
Now, what are the wires coated with?
Like I don't know what it is, but I'm guessing it's like some different type of plastic.
Yes, indeed.
But it's not
That
like
is
normal plastic that we see.
that is also PVC.
like PVC pipes that are used in plumbing?
Yes, yes, exactly. There's
Oh, wow.
slight modifications that are made in this to get that structure there. Okay.
Oh, wow.
Yeah.
Okay.
So what is PVC? It's polyvinyl chloride.
There's fluoride in
Polyvinyl
there?
chloride. Yes, there is. There is. Apart from which you have carbon and hydrogen as well. Okay.
Well, you have carbon. Well, wherever you have carbon, you'll have hydrogen. Isn't that right?
You have, yes. What do you say? Organic chemistry, hydrocarbons. Yes.
You
That's the
have to have
name.
that like in every single thing.
Yes. It goes by the word hydrocarbons.
But isn't that even like without organic chem?
Mhm.
Hydrogen will always be present wherever carbon is, and carbon will always be present wherever hydrogen.
Need not be, need not be, need not be.
Oh,
Yes. For example, which gas do you exhale?
see carbon dioxide?
So is there a hydrogen in that?
No, there isn't.
There you go. So when we deal with this branch of chemistry,
Yep.
okay, organic chemistry, and when we talk about hydrocarbons, yes,
Okay.
we are going to deal with those that part of chemistry which has this long form chains of carbon and hydrogen. So you know what is polyethylene now? You know what is ethanol? You know what is
Yeah.
PVC? It's polyvinyl chloride. I'll ask you another question.
Okay.
Have you ever heard about polyvinyl acetate?
Polyvinyl acetate.
Yes.
No.
Okay. Do you use adhesives?
Adhesives?
Adhesive. ADHESIVE.
No.
You must be using. What do you use to, if you have to stick something or paste something?
Then you just use glue.
You use glue. That glue
Oh,
does
adhesive.
contain, yes, that glue contains this polyvinyl acetate. Okay.
So yeah, like adhesive tape and stuff like that.
Yes, exactly. Adhesive tape. So here, there's again involvement of carbon and hydrogen. Even that comes from hydrocarbons. Okay.
So everything that just doesn't include us has carbon and hydrogen.
Yeah, exactly.
Okay, great.
Now, for example,
Except for plants as well.
yes,
Right?
yes. Now
Yeah.
you have your beds, right? On the bed, you do have your mattresses.
Yes.
Yes. So sometimes most of them do use this foam mattresses.
Yes.
Even they include hydrocarbons.
Then that includes a lot of hydrocarbons.
Yes. And even all your molded plastics.
Well, no, I know that molded plastics would have that, but
Yes.
what
Molded
about like,
plastics are all hydrocarbons here.
oh wow. Okay.
Yeah.
So if I put it under a microscope, do you think I'd be able to see it?
Not really.
Oh.
Yes, but you can see if it's under an electron microscope, you do get this. What do you say? The network of carbon and hydrogen atoms, in in the cyclohexane shape. You do.
So it is visible. So you
Yeah,
can
it
see
is.
the
It is.
carbon and
It is.
hydrogen.
It is. Yes. And
Oh.
apart from, of course, these of course can be synthetically prepared in the laboratory. Now, the next thing what I'm going to tell is those alkenes which occur naturally. Okay. So one such is carotene. Have you ever heard about carotenes?
Is that like a type of jewels or something?
No, they're found in carrots.
Oh, it sounds like something you'd find in jewelry, but
No,
oh, okay.
no. Oh, you went towards carrots, right?
Yeah.
CARAT. I was mentioning about CARROT. Now,
Oh,
generally, what color carrots do you see?
oh, orange.
Orange. That is because of this pigment called carotene in it. Okay. So that's an alkene again. Understood? So
Yeah.
next time, whenever you lift a carrot, you should know that that's an alkene what you're actually holding in hand. Next, you must have heard about ginger. The oil of ginger does contain an alkene in it.
The oil.
Lemons, yes, lemons.
Oh, I know
Limonene.
what lemons do.
Lemons do have an
People like
alkene called limonene. Even
people
oranges do have, yes.
use lemons oranges and
Mhm,
potatoes
mhm,
like
mhm.
use electricity.
Yes.
I know that those three have it because
Yeah.
lemons and oranges are like pretty citric.
Yes.
I don't know how it works, but apparently the more citric it is, the more
Yeah.
electricity or something.
Yeah.
And then potatoes are just highly starched. So yeah.
Yes. Yes. Yeah, they do have a lot of starch in it. Next, talking about apples. Now, if you closely look at an apple, you find a faint waxy coating on it.
Yep.
Yes. Even that's an alkene. That's called as famicene.
I thought the company
Okay.
just put it on there.
Okay. So, so these are some of the naturally occurring alkenes. Okay. They're not synthetically made
So
or
they
something
just
like that.
automatically get made. So like as a
Yes.
carrot grows, when we're talking
Exactly.
about a carrot
Hmm.
starts from like that tiny and it comes from a
Yes.
green stem.
Hmm.
So it just more alkenes just continuously get producing as the carrot gets bigger.
Yes. Exactly.
But the whole thing is like orange.
Hmm.
Wow. This has really opened my eyes. Organic chem is
Yes.
opening my eyes.
And now I'm just waiting for your college to start off because I don't know which areas are they going to tap. So even like whatever I've explained now, you're still in the perimeter.
What does that mean? Like this.
Yeah, when I say perimeter, assume, okay, your entire college building to be
Yeah.
the organic chemistry stuff.
Oh, God.
So you have a perimeter across, I mean, around the college,
Yep.
the wall built. You're
Yep.
still sitting on the wall. You haven't entered the building actually.
Oh, God. I
Yes, the
thought
amount
you
of
already
organic
went
chemistry,
through.
whatever I've introduced so far, is just the perimeter. Okay, you're just looking at things just from outside. So that's a huge, huge subject as we dive into it. But that's the reason I
At
asked you,
least
like, what
a
happened at
really,
college
really
today?
big assignment also comes out on this.
Huge. Big is a very small word for that. It's a huge assignment that would be coming up. Because once you enter into this IUPAC, where you have the structures, okay, the way you have to name it, that's a big ocean.
Oh,
Okay, yes.
okay. Well, I might still have like 3 days left. She introduces it tomorrow, I might as well just drop out of chemistry and just, yeah.
Why?
I don't know. It seems really complicated. So,
It's not complicated, but you just can't drop out, right? You have to learn the subject, right?
no, it's a choice. I still have about 2 days left. They're like, if you still want to make course changes, you totally can. So if she drops the bomb tomorrow, I'm out. I'm out of that class. My parents won't let me, but mentally I'll be out of that class.
No, 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 no. Don't give up.
I can't anyways, at least for university I can't. Oh yeah, I've applied to like a university in like Germany. So now I'm like learning German.
Oh,
Because yeah, university in like Europe is so much better than coming to Australia and learning
that's
apparently.
right. That's right. You're
Is
planning
that
to
true?
move there?
Well, I mean, like if I totally get in, then yeah, I'm off. My parents don't know yet, but when I get in, then
Oh, so
then
you
I'll
still
drop the
kept it
bomb.
under wraps. You still
Yeah,
haven't
no,
opened it up to your parents. Okay. So then
yeah, no,
have you started learning German?
yeah, I started today.
Oh my
I only know how to
God.
introduce